let's try to do a little bit of experiment, and let's make it a little bit more abstract. Okay, let's start with that integer. Why integer? Why a list of integers? Couldn't that be just a list of anything? You know what? Why? Because why not? Right? I could basically say, you know, you're gonna sum me a list of a's. So a here, and I'm gonna give you. Sorry, I'm gonna give you a. Another question would be, you know, how to sum those things together. Well, we could say A is a semigroup, right? We could say semigroup, which is awesome because right now we could just say we have the plus operator from semigroup, right? But sorry, we don't know. What about 0, right? Obviously, when you fold. Wait a minute, that's important. Who's not familiar with fold? All right, fold. Let's say I have few people here, right? Guy over here, guy over here, and guy over here. And I'm asking you, who is the oldest in the group, right? And everybody has a piece of paper with their age. This guy is like 12. This guy is like 13. And this guy is 10, okay? I guess children. So I'm starting with a piece of paper, and I'm putting a 0 element on it. And I'm giving this to the first person, and I'm saying, listen, well, this is an example we are, so let's say, okay, let's stick to this example. I don't want to find the highest age, who is the oldest. I want to sum all the ages together. Like, I want to see, like, if we sum all the ages together, what's the value? So I'm giving you this paper with 0. I'm telling you, take this piece of paper and add value from your piece of paper, and whatever is added, pass to the next person. So he takes the 0. He has 12. 12 plus 0 is obviously 12, and he passed the paper around. And then this girl is like, okay, this is 12. I'm 13. So together it's 25. And she puts 25 on it and just pass it one more step. And the guy's like, okay, 25 plus 11, that's 36. And he gives me the value 36. And this is basically what fold is doing. And depending on, like, there is a fold left, fold right, and then there's a reason for you to fold left, either from fold right. I just don't want to go into those issues details right now. You can always read about it. But basically, this is how fold is working. Okay, just this ability to merge the list, merge the structure. Okay, with a 0 element, the starting element with 0 value, and the function that we will call with the last accumulator and the value on the element. So we accumulate that value towards the final result. So the plus is all fine because we have that from semigroup. But what about 0? What's the answer for it? You already know. There's already type class for it. Excellent. So if I go to Scala Z, there's a thing called monoid. Monoid. And a monoid is just a semigroup with a 0 value. That's what it is. If it sounds scary before, it shouldn't, because you already know what semigroup is. So it's a semigroup, but it also has a 0 value. Let's think about this for a minute. What would be the 0 value for, or maybe what would be append for integers? Plus. Is that the only append possible? What is also associative with integers? Multiplication, right? So it doesn't mean like with integer it has to be adding things together. It might be multiplying. So it depends on the instance of the type class, right? And the 0 value would be what? For monoid, for integer? It depends, exactly. So if we had the operation would be plus, the 0 value would be 0, right? If the multiplication, then the 0 value would be 1. All right, awesome, you get it. So now so basically I can just say monoid for my A and 0, right? Yeah, and I have to say this is actually a monoid. Bias. Okay, so now at this point I already removed some elements from the scope of possible solutions, because look, well, obviously 0 could still be here, right? Because 0 we get it from monoid, but right now I have no ability to pick any arbitrary value from like possible values, because once it was an integer, right? I could just say like 12, and it would compile and it would work. Now it's just some, sorry, it's just some A. I don't know what that A is. So I cannot say, like, I cannot put any arbitrary value and say whatever, because I don't know what A is. So this thing disappears. I could still do pattern matching against list, and just, let's say, take the first element from the list and remove it, and I could still fold it. But that's not the only generalization that we can make to this function. Sorry. We could say we are not using a list. We're just using some f. Okay? So now it's no longer a list, it's an f. Okay? But now the problem is, like, what can we do about that? Right? So we will say there is some f, like with you know, obviously with a hole here, right? And that A. But what now? And you know the solution. There's a type class for it, exactly. And there's a type class, and Scala that called foldable. And I'm not at this point. I don't want you guys to actually like memorize all of the possible type classes. I'm just saying there are solutions for it. And if we look at type class foldable, it has some methods that we need to implement. We need to implement fold map, and I'm not gonna right now reason about what fold map is and how it should be implemented. Well, I would like to show you a cool feature. There's actually a method fold. Let me look it up and check the signature of this method. So this guy over here. This guy is saying, if you have some f of m, and m is a monoid, I will do the magic for you. I will just give you the m. So now in our implementation, I can just say f fold. That's it. That's all. It works. Hopefully it compiles. No, it doesn't, because I have to say f is foldable. So I have to say f is foldable, and compiles. So now can I still return 0? Well, I can, right? Because I get 0 from monoid. Can I pattern match against f? No, because now I don't have list that I could pattern match against. I don't have like a concrete type that holds my A's at this point. I have some f, and the only thing I can do with s is just folds it. So I then cannot do this. There are right now 2 possible solutions in all the scope of possible solutions I can speak of. I can either choose 0 or fold. Isn't that better than having tests? Now languages, strongly typed languages like Iris or Agda, where you will have a method signature, and there is only one possible solution. And yes, that solution can be auto-generated. So no longer Stack Overflow. You just type signature, and the computer do the rest for you. Wouldn't that be cool? We don't have that language, but we are pretty close. John actually have a whole blog post about it, and if you guys are interested, and I'm one of those examples I actually reused from his blog post, and he goes into more details about it. But I'm just saying this thing, for me at least, shows the true nature of going into more generic implementation. I not only get more power in an ability, so now my function sum, because previously sum could be implemented only for lists of integers. Now that cannot only be for integers, it can be for anything. It can be for user. As long as you know how to add 2 users together, then you're good. But not only list, it can be a tree, it can be any data structure that holds your users. This is more generic, so it has more power for the users who are actually using that function, but also it is more robust. If it compiles, you are almost 100% sure it works. As obviously there are 2 ways to implement it, but again, infinity versus 2, I will always go with 2.
Can you write an example of using this sum?
Obviously. So I can just say, let's say I will call sum with list. list of 1, 2, and 3. Right? And now, yeah, I have to print it actually. Right? So, there you go. And there you go, 6. The default monolith for integers is plus, but there's also one for multiplication. I took advantage of obviously of type inference, but I could just say, if I want to be more explicit, I would just say list and int, right? But the compiler was smart enough to actually learn that from the values. But this could work with tree structure. This could work with, okay, I can actually call it. So let's call it with A and B. There's also a monolith for string, and monolith for string is just concatenation of strings. It follows all the rules, right? It will if you have ability to concatenate two strings, and they are the operation is associative. Okay, let's make a break, and after the break I'll show you one more thing cool, and if you're not convinced, then I'm sorry, but this will be really, really awesome. But let's make like a 10 minutes break. What's that?
The code, backup, the code,
Yeah, definitely. So like 20 past 2. Proszę?
Nowa drama.
Jaka drama? Jaka drama?
Murzyn, co było na początku? Drama.
No.
To jest jakiś men's right activist.
Kto to jest?
Jakiś men's right activist.
O nie.
Kurwa, to specjalnie zrobił.
I już świrują. Amen.
Just a silly question about Scala.
Definitely.
Sometimes you call a function with multiple groups of parentheses.
Oh yeah.
Is this because the first call is
Okay, so let me.
Is this like a current function?
So basically in Scala, and it's you don't have it in Java, but in Scala you can. So I can have a method, whatever, right? And it can take let's say an integer, right, and string, right, and it will do something, right? And so I will call this with 10 and whatever, right? So it's a single parameter list with 2 arguments. But you can have in Scala, and you don't have it in Java, you can have multiple parameter lists, like that, right? So now I have 2 parameter lists, each one holding 1 argument. And now, what's the difference between those two? None. Only your syntax, a little bit of being. So for example, like if for example, the type inference, that's one thing, yes, in Scala. But otherwise, that's true, right?
If you have the second set, if you have type parameters that are Scala is able to do type inference on a function based on previous sets of parentheses. So if instead of s string he had a type parameter a to a, and it was based on if I was type A and s was a to a, you would not be able to pass in an arbitrary lambda as a second param if you didn't have them broken into 2 parentheses.
Yeah, and that's just a Scala thing. It's not the feature. It's sort of like a bug. Yeah. But there's for what we're doing right now, you wouldn't see at this point any difference. It's more like a synthetic, whatever you want to use. It actually makes sense sometimes. So for example, if I'm folding, right? If I have a list, right? It's sometimes people tend to. So for example, if I'm would fold be okay? So if I have a list, whatever list, right? At this point, right? And then do map, and let's say it's users, right? So it's users, and I want to map them, and then I actually really. So what I could say, like, I could just have a user, right? And I could just do something with a user. But let's say user has a project, and that project has a department, and that department has a boss. So I have to go like user, that project, that department, that boss, right? And instead of doing that, I can always make, as you've seen at the beginning of this workshop, I could just do pattern matching. So I could say, like, user, right, and I would just say, like, I'm only interested in where the department has a project which has a boss right here, and I would say, and I'll do something to that boss, like say like login or whatever, right? So you can use pattern matching and when you instantiate lambdas. So now, for example, if I have, so this is just to show you that you can actually use pattern matching and when you provide lambda expression to function map, right? So for example, if I have users and I want to do something to the, for example, fold left them, and I have some like a users. I'm just trying to think of some examples. But just say user 0 or whatever, right? This and this function here, which concatenates two users together, right? I could do it in those braces like here, but I could also do it with like I could just say like case, and this is a tuple, right? And then user 1, user 2. But I can also and I can then do something to it, right? Whatever I want to do here. But I say like with pattern matching, I can do the composition of the structure, and it's just a nice feature if that second argument is within the second parameter list. You can do this thing. It's just a nicer way to look at your code base. But there's no meaning to whether you will use 2 arguments in one parameter list or whether to 1 arguments per 2 parameters, other than the inference type, which is more like a bug in Scala rather than a feature. Bro.
You briefly mentioned that the default monoid for int was summation.
Yeah.
That implies to me that like it's defined for products and whatnot. How do you tell Scala if you're not going to go there? How do you tell it, hey, I want product instead of summation?
So if we will go to, I have to remember what that is. So let me just, is that Scala? Is that? Yeah, it is. So if I go to a monoid and or semi-group. Did I miss Scala Z? Wait, okay. Scala Z. There it is. Okay.
Yeah, exactly.
Okay, now. Actually, I never used with a product, but we can try to find it out.
Okay.
So, and now there's so it's defined example instances. Okay, so it has to be somewhere here. Monoid for and okay, it's not here. Let's try to look at it one more time. Sorry, monoid and okay. So any-val monoid. Okay, so you see there's an instance here for integers. So we have inst value with plus. So that's the inst instance, and the question is, do they have? And there's one for product, and you use it with tagging. Okay. So you can tag your. So this just. I think
probably have to put that in the invocation of
of type. You say I have an int, but you would say your
tagged as multiplication.
Which is say this, gotcha. Right? Okay. And it would find the proper instance for you.
Okay. Or it would complain if one doesn't exist.
Yeah, exactly.
Okay, cool.
One quick question. So I think. Oh no, I just deleted that. So I'm assuming what's happening here is the default implementation of fulls is calling. So where's the sum operation?
Can I show you this?
Yeah.
That's how fold is implemented.
Yeah, and it hits fold map. Yeah, I had that pulled up.
Yeah. I'll just put it here, so we will see it. Right? So it's basically this is our fold. This is fold using monoid.
Yep.
And it's calling fold map with identity function on that f. So that's I have to reason about what fold map is doing, right? So mod fold map will take your a crossed over some structure, so like our integer crossed over list, you need to have a function that goes from integer to something. In our example, it's going from integer to integer, and it will give you that something. In our example, that's integer.
Okay. And then
So it's traversing so while it's traversing the structure, for each of the elements, it will also call. It will first use the monoid because we don't have that implementation, right? Somebody has to implement it, but we give him the monoid. So let's say with lists, right? With fold map, it will go like this. This is the list, right? I will start with 0 element, which I have from monoid. Then I call append from monoid, which still gives me the value of a, right? And then I have a function from a to b, which I can convert to b at the very end. So I'm summing all the a's. Finally, I have an a. Let's say integer, but I have a function fold map from integer to string, and then just call that function at the last result.
So that if we did this on some, I'm assuming like all the default types, string, int, etc., are all have in Scala Z built-in implicits. We would have to define our own implicit if we wanted to do that. Okay.
We have default, integer, string. So for string, it's a concatenation. For integer, it's either adding things together or multiplying, right?
Okay.
Yeah. So for all those products, and then you will have. Then they will have the craziness. Like for example, if I have like this tuple, right? If I already have a monoid instance for integer and string, can I get it for free a monoid instance for tuple?
Wouldn't you have to write your own implicit that uses those two?
Yeah. If I have a tuple of a and b, and both a and b have monoid or semigroup, I could write a semigroup instance for tuple as well, because I will add. I have 2 tuples. I will take the first element, sum it together. Second elements, sum them together, and out of those 2 results, I will create a new tuple. And there you go.
And then you got it.
Yeah.
Awesome. Thank you.
No problem. Jak? Można nadążyć, czy nie?
No ja to nadążam jak najbardziej.
To dobrze. Bo to tak, dla takich ludzi jak ty to jest stworzone, więc... Nie, właśnie nie. Ktoś to siedzi w skali, co nie? Trochę klepał i...
No dobrze, że się mi klepał po ryju, bo w sumie na początku powiedziałeś, że trzeba znać skalę, a potem były głupie pytania o skalę.
No właśnie...
Dobrze, żeś to wrócił. Tak
Nie,
do dzisiaj tłumaczę.
do dzisiaj mi tłumaczę, dokładnie tak się obawiałem, co nie?
Asertywność, dobra.
No. Adam jest na magii, pokazywał mi przykłady z tego, co ono tam ogląda. Jesus Christ. A że to jest niezłe, strasznie mi się...
Wysłał parę tych gry w życia mi wysłał, jakieś szlaczki. Ancient Runes. Potem za 7 miliardów lat odkopią te piramidy i tam będzie kod właśnie w tych zapisany. No krwieni co to jest, to gra w życie.
Co oni mieli na myśli?
Co oni myśleli?
A w ogóle z tą dramą, to ja po prostu John widzę, że się nie pierdoli, co nie?
To już kurwa specjalnie.
Tak, to jest zrobił specjalnie. Ale to dobrze. No jest początek takie murze chrześcijaństwa, jak kiedyś mówili o Polsce, co nie?
Ale to jest po prostu jedyny level, który jest konsekwentny i to po prostu rozsierdziło wszystkich dookoła.
Muszę zacząć tę dramę.
No wystarczy wejść na Twittera, hashtag LambdaConf, tam praktycznie nie ma nic o konferencji, same dramy tam napierdalają. Jest to konferencja dla white supremacist.
Tak, który mówił czarny człowiek, tak?
Wystarczenie.
No nie ma znaczenia, no okej. No.
On by sobie mógł być, wiesz,
Zielony, co nie? No. Masakra.
czym wysłałem 0 days since last taką dramę.
John, are we good with microphone? Is it still working? The battery. The battery, is it still working? Właśnie. Yeah. What's that? Break it? 20 minutes to what? 40. Yeah, I know. I do apologize.
40 minutes break?
Till next break, right? Okay. So, I'm going to show you something which was supposed to be an exercise, but given the time limit, it will not be. I will do the exercise for you. But I think it's actually a neat feature, and this is like my last attempt to advertise implementing your functions more in generic way. If some of my thoughts I was telling you about the smaller number of scope of possible solution and making a function more applicable to different types is not enough, let me show you something I hope from like a real world. So I'm going to show you a few problems and then we will try to solve them. So problem number one, and this is something like if you did Scala before, you've seen those problems most probably. So let's say I have something like of a type task of int. Okay, this is what I have. I don't know really how I got this, but if you work with stuff like, for example, akka streams and Scala, this is eventually what you will get at some point. So you have a future of int, or most possibly a future of int. And now the question would be, well, okay, but I really what I need is just a task of int, right? So that would be the first like one of our problems that we want to implement. Now the other problem would be, let's say, so problem number 2. Let's say I have. This is also what you can get from one of those frameworks. Is let's say I have a list of tasks that gives me some value, let's say like integer, right? So it's going to be something like list, and let's say I have a task now 10, and let's say I have a task now 20. And what, okay, you guys don't see it. So what I would like to have is so solution 2. What I would just like to have is just basically a single task that will give me a list of integers. That's what I need. Okay. So this is also like a typical problem in Scala. Well, obviously I'm changing task to future, but this will work with future as well if you provide proper instances for future for the type classes that are needed. But this is also like a scenario. I'm fetching those different things from different resources, and I'm getting a list of tasks. But I would really like just to have a single task that will calculate me that final list as my result. So yeah, let's try to implement this. So as it turns out, if we're gonna look at the bind time class, there's a neat method called join, and join is implemented for any A's as long as they are closed over f, which has a type class bind. So if I have a f of a, I can just pretty much call the join on it, and I will get f of a. So if I, in my problem 1, if I just say problem 1 dot join, it will, let me comment this for a minute. This will compile and work. That's it. That's all you need. Solution number 2. Problem number 2. So now I have the list of tasks, and I would like to have a task of a list of integers. Well, there's another type class for it called traverse, and traverse has a method. Let me find it, which is called sequence. And what a sequence is telling us is that, listen, if you have an f of g of a, I will give you g of f of a. That's what it's doing, as long as g is applicative. So it's just, so I have something close. I have an a closed over g, and that g is closed over f. Well, I will just put it upside down. I will give you a g of f of a. If you have instance of that type class, then you get that method for free. And this is pretty much all we'll be doing. So I will just call my problem 2 sequence and compass. And so, problem solved. And the reason I've shown you guys those 2 examples is I've seen so many ways to actually implement the solutions to those problems. The craziest solutions that you can think of. Like, the amount of magic and playing around with types was just enormous. But I have this for free. Why? Because somebody who was doing this library figured out, well, actually somebody might need this, but why make it for future or task and list Let's make it as much as generic as possible, and as long as the type will fit into our signature, we will get that functionality for free. Traverse comes also with one more function, which is called traverse, which is also one of those problems that you would normally find it also in imperative programming solutions. In Scala solutions, which are more imperative. So, let's say I have a list of IDs. Okay, so just a list of integers, 1, 2, and 3, and also I have a function which is called fetch user. So it and let's just say, that'll be a function. So let's just say it's a function that takes the integer, right, and it will give us a user. We need to have a user first. Class user 2 login string and I don't know, an ID, right? So int. So it will give us a type. Is there a user here? No. So I can actually call it a user. So the idea here behind this is that I have a. Let me just type it. I have an integer which is an ID, and that function will give me a user. So new user ID, I don't know, login ID. So the idea is that I have some list of integers, and I also have a function that will have the ability to fetch the user from some storage. Postgres, Oracle, I don't know, Cassandra, whatever, right? Whatever you have. Since calling Cassandra on Oracle will actually modify the world, or just it's effectful computation, I close all the effectful computations over tasks. Would it be nice if I could just call what I really want to have is a list. So val users, a list of users. Would be nice if I had it, right? And if we actually, so there's a function called traverse. This one here. So f. So just to give you an f is our so a. Okay, so a is our integers. F is our list. So now we have here a list of integers. We also have this function that will go from integer to and G is our task. So we will have a function that will give us a task of user. So B is a user. So now if we give them both the list of integers and fetch method, what we will get? Well, G was task, so we will have task of list of users. So so not this. I will have a task of list of users, and the only thing I have to do is on the IDs called traverse and adding the fetch user function, and compiles. So if that is not a selling point, I don't know what is. Just a second. The thing is, there are so many things that you can solve when your code is generic. It's more abstract, and at first you seem scared because it's just an additional set of syntax. But then if you really think about it, some might say the foldable example. Yeah, I would rather fold lists of users rather than some F structure, because I know users, I know it's a list, I know what kind of type I'm dealing with. But are you really? I mean, you only know you deal with lists, right? But you're using a specific subset of functionality from a list. So what's the point of talking about lists. If you're only using this one particular subset of functionality, leaving all other subset of functionalities open as a place to exploit. Because I know none of you guys provide bugs to the development to the project. Right? It's the other guys always, right? The junior developer. I know all that. But if we could just write a type signature where junior developer has no ability to make an error, wouldn't that be nice, right? And then we're no longer pointing fingers. Oh, it's Tom's fault. Oh, it's Mike's fault. Because the compiler will be like, humans, it's all your fault, but I'll deal with that. It's just having more abstract implementation gives us a lot of power. And hopefully I was able to actually show it. Question?
What's the difference between traverse and traverse view, sequence?
We don't really have time for it, but the best thing to actually learn what that is look at the source code base. And sequence is actually implemented with traverse. So if we look at sequence implementation, sequence is just traverse where the function is just giving us it's like an identity function. It's not changing the result type. I really like, it's like, 2:30, so I have to, I'm happy to answer that question, but maybe after that workshop if you're still interested, okay? Does that make sense? Yeah. Okay. Not here. All right. So there's an exercise for you guys. And exercise is pretty simple. It should be pretty straightforward. There's a merge function. It's very stupid implementation of merge function. So I have two maps together. They all have the key string and the value integer. And what we like to have is ability to merge those two maps together. So I will still have a map of strings and the values will be integers. So if the maps have the same key, I'm adding two integers together, right? Like so I'm taking for each of the keys, I take the value. If the value doesn't exist, I just say it's 0. If it does exist, I have it, and then I add it to value from a second map, and now I have a new value for that key, right? And the exercise is to make this method abstract. Oh, and I would just say up front, like if you actually will import Scala Z sources, the solution will be just this, right? Because this function is already implemented in Scala Z. But I don't want you guys to actually re-implement what's already. I want you guys to re-implement what's already. So don't use append operator for map because they obviously implemented a monoid for maps as long as the B's in those maps are monoids as well. But instead of just reusing Scala Z, treat this as an exercise and make this method more generic. Like 10 minutes for it, and then we continue. So now merge you have a type signature on line 5. So the merge function will not take two types parameters A and B, and we will have two maps parameterized by both A and B. And we want to have at the result also a map of A and B, where A is a key and B is a value. You obviously need to, which I forgot, add the import to Scala Z, right?
Are we doing this for any AB or for A and B being a monolith?
Well, I need you to have this implementation running, like whatever less powerful, the better.
Okay.
If you can make A not monoid and only B monoid, that would be great, right? Because it will apply to more types.
Sure, but you could implement it with neither as a monoid and it just filters out the ones that aren't B.
Well, but why do you want to filter out? I want to have everything. I want to have every key from M1. I want to have. I want
map AB.
No, I want to have every key. I want to have every key from M1. I want to have every key from M2. And if there have collision, if there was the same key was in M1 and M2, I still want to have that key in my solution. I just want to merge the two values together.
Sure.
Okay, so basically this is what we have here. It's the solution. So what I did, I said match will now be parameterized by A and B, where B is monoid. So M1 and M2 are maps of A, B. I said I just have this value 0, which I took from the monoid B. And just saying, give me a value 0, append with append from monoid, and also 0. And that's basically it. That's the whole solution. Okay, so before, we will have a break at 3, don't worry about it, I remember. Now a little quiz. What's a functor? Anyone?
Something that has a map.
Yeah, has a map, right? And applicative is apply, but also adds a method. What kind of method? Point, exactly. I guess I think you guys get it. I did a good job, yay. I have a question. Yeah. Yeah.
What about those laws that you mentioned? For instance, in
Yeah.
the associativity law that exists in semigroup?
Yeah.
Are these laws enforced by the type checker?
No. So so the question is whether the laws for the type classes are enforced by the type checker, and they are not. However, both in Scala Z and in CATS, whenever you have like a type class which they defined, they also defined a set of tests which will they give you like a guarantee that if you can run those tests with your newly type created. So let's say I have some structure and I just implemented like a user, right? And I implemented a semigroup in type class for it, the instance of semigroup type class for user. I can run those tests for my instance of my type class semigroup, and if the tests will pass, I'm good. So unfortunately, this is not something you could guarantee on a type level, or compilation during the compilation time. I have a question though. Like, if is there a person on the audience, and please don't be shy, to say like they don't see this abstraction and making functions generic. They think it's a stupid idea. Because I believe definitely there are people like that here. I just want to hear your reasons. Or if you're afraid to say so right now, could you, after this workshop, talk to me? Because I want to also explore what people think about it. For me, yeah.
I get the power. The part that I'm having a really hard time wrapping my head around is when you're working on business logic and you do have strict types and you're not working and you don't need the power of why would I choose to go through the extra hurdles of implementing?
Yeah, I get that. So Now that's the issue, that we only have 6 hours. And the problem with functional programming is that to understand like some things a little bit more advanced, you have to work your way through from some bottom to the up, right? And there's the reason for that. But do you see for that, at least from the library perspective, why that would make sense? Okay, so there is a reason to, if I'm dealing with business logic, there's a reason for that. I want to be also abstract and generic as much as possible. And I hope we will get there within our time limit, but we have like not more than 3 hours to do so. So I hope we will get there. And if we are not, if somebody will be still happy to talk about it and see, for example, like business cases, I'm happy to show the code base and some examples that I have, or maybe even the project I'm working on at SLAMDATA with Quasar, which is open sourced. So that might be also a good idea. We actually can show you, but at least for the libraries, that makes sense for you. Okay. But yeah, being generic in business abstraction also makes sense, a lot of sense. And I hope we will at least scratch a little bit of surface of that as well. Okay, so having that, let's go to, I don't remember. Oh yeah, there it is. Okay, state. And there's a file called attempt1. So attempt1 isn't really a functional. I could show you what state is by just showing this little problem one more time and saying, well, there's a type class for that, right? But I will try to do so right now with a little bit something that would at least a little bit closer to real world, which obviously it isn't because it's just too simple. But this solution that we see here is closer to you would normally see in OO world. And I will try to right now reason about problems that you have that with solution and how state could actually help you out, and that would just make some things more explicit in not implicit how it is in the OO world. So I have a user. Awesome. And so the user is just basically some structure, an ID, first name, last name, and that's what it is. There's also a trait representing cache. Cache or cache? How do you pronounce it? Cache. Cache? Okay, cache. So I can get a user from cache. I can insert user to cache. I can also get him, and I obviously will get an option because the user might exist, yes or no. And there's some contract within the cache that if I try to get the user and he actually exists in the cache, the number of hits will be increased by 1. And if he doesn't exist, the number of misses will be increased. And that's for some performance issues. Whatever, I don't really want to focus on that. So we will have, and yes, one more time, this is not FP, right? This is more like closer to OO. So now we will have cache service, which basically extends the cache, and we implement it using map. So we have a variable map here. So when I'm inserting a user, I'm just saying a map is a new map with that new user added with the key and the value. And when I try to get a user, what I will do if I'll first see if something exists in the map for a given ID. If it does, then I will increase number of hits. If it doesn't, then I will increase number of misses, and then I will give you back the result. Because if you call map.get, if you call a .get map, Jesus Christ, if you call .get method on map, you will get an option of that value. Okay, so this is just implementing that service. There's also a one more time. There's also a repository. So this sort of like represents database or whatever, like your Cassandra, and has a method find. So find takes an ID and it gives you a disjunction. It will be either an error, like whatever that error might be, or the user that you're looking for. Because obviously user might not exist in the repository as well. And we have some implementation of the repository here. Obviously, here you have some like JDBC calls, Cassandras, whatever. But I'm just, I just have like some returning some simple value. But you can imagine we have here have some like a code that will communicate to the whatever storage that we have, and then we implement a service, user service, which takes which takes both of those traits, cache and repository, as arguments, and has a very neat function which is called find by ID, which takes an ID and will give us a disjunction, either string or a user. So what we're doing, we're calling cache because maybe the user already exists in cache. If it doesn't, so it's a kata method. It's called fold also. It's a function that you have on option. So what you provide to this function are two lambdas. One which will be triggered if the value exists in option, and the one which will be triggered if the value doesn't exist in the option, right? So if the user was within cache, so we have something in option like a user, we just call write on it, and this will give us the type that we want to return. So this disjunction, right? If the user was not available, wasn't in cache, then well, we will do two things. We will first of all call find user from the repository. That will give us the disjunction. And we will call on that user on that disjunction map method. So it basically means if actually user was returned, his user is on the right hand side, we will also insert that user to cache. So that next time somebody calls our method, he will be within cache, right? And then we call that u. Makes sense? It's pretty much what you maybe might implement using Scala. And obviously we have some awesome cool framework, whatever that is, for dependency injection. So we have the user service, and there will be like a Spring or whatever you're using that will give you the right implementation of both cache and repository, which you can use in production. And it seems like there's nothing wrong with this design, right? Is it? I would say it's like readable. I could pretty much reason about the code base if I've seen it for the first time. Maybe I would like think about it for a minute, but there's no like additional magic. I could probably understand what the code is doing. So this is how I would then implement my tests. So those tests are implemented in comments because I just said like no way I'm going to use Mockito to this project. And also I was after my hike, so. But let's just imagine this compiles and actually work the test that makes sense and you can actually run them. So the first test, it doesn't look really scary. It's testing whether that can find a user if he's within cache. So since my user service is taking both cache and repository as dependencies, I obviously have to mock them. So I will have some ID, I will create some user with that ID, I will mock my cache over here, and then I will say, well, given if somebody will call that cache with that ID, I will return that user, right? So I'm implementing here like a recipe within the mock saying, if the user is within cache, then return that user, right? And then I will instantiate my user service with both my mocked cache and also mocked repository. Obviously, I don't have to do anything about the repository because the implementation is that if the user is within cache, we just return and we don't call repository at all, right? And then I call my function by find by ID, and I just check whether the result that I get is actually the user that I've inserted previously into the cache. Now the question might be, does this test make sense for you guys? I would say it has two flaws. And the problem is that, okay, so how many of you guys actually write tests in your code base? Awesome, keep your hands up, keep your hands up. How many of you guys had a situation where you deleted you changed a little bit of your code base and like 20% of tests were failing? Yeah, okay. So how many of you guys actually had a situation where your code base was, your tests were using mocks and somebody deleted implementations and the tests were still passing? Yeah, so you've seen all that. And it's basically, so this is one of the things, is that if you really look at this test, it's not really testing. This is not really what it's lying at this point. It's telling you if I can find a user if it is within the cache. But what test it's really doing is testing whether all the steps that you implemented here, all the steps that were needed to provide this implementation, are fulfilled. Because when you use those mocks, you're checking. Okay, so you at this point you're saying somebody will have to will have to use a get method on cache. So you're now fixing your coupled within your test on your implementation. If somebody wiser than me came into this project and re-implement the body of this function, like this, let's just imagine the signature stays as it is. It still takes the cache and repository, right? And it's still doing the same thing, but he did a little better. I don't know, he used better APIs or whatever, right? If he just changed the body, but he keeps the original solution the same, this test will crash. It will fail. And it will fail for a reason, because it's not testing really the functionality. It's testing whether the set of methods I'm calling over there are actually being called in the right order. That's what it's doing. The test is not really interested in the result. It's more interested in the steps that are being implemented to actually get us to that result. Other question is, should I test whether the number of hits was increased within this test? Should I test it? I would say yes as well, right? But with this implementation, you can really do this. Why? Because what you get here is just a trait. It's just a trait, and just a reminder, trait here was just saying, well, if you're gonna get a value from me, I should probably increase the number of hits or misses. But it's just a contract, and you only get that trait. The implementation, it's part of the implementation detail here in that service to actually increase the number of hits or misses. So you cannot really do that here. You cannot really assert this, because you only deal with a trait. You don't deal with a concrete implementation. But that's not really the problem as well. The other problem, 5 minutes till 3, awesome. The other problem is, let's check the other test. The one that will tell us, well, given that I do apologize. I know you don't see everything on the screen, so I just have to, this. Okay, so the other problem was, given that the user is not in the cache, so the should be is not in the cache. So given that, I should find them in the repository. And one more time, we have we're just implementing the number of steps that needs to be created. So we have a cache mock, and we're saying, well, if you call us that cache with that ID, I will give you none. And then we also mock the user repository, and we're saying, like, if the repository is being called with that ID, we should give them a value. And we call one more time find by ID, and one more time we get a result which is asserted. Now, this has one additional problem, and the problem is, in this implementation here, you're saying my user service depends on cache and repository, and your tests are taking this as for granted, and they think those services are independent, but they don't have to be. My repository service could also take here as parameter cache, right? And the logic I could implement here could be something like one more time. I could re-implement this logic, because I want to be smart. Somebody else, is this junior developer, wants to be smart. Not me, right? I'm always perfect. But this junior developer want to be smart, and he will also we'll do some additional logic. Like, for example, if found in repo, then add to cache, right? And now you have this method insert being called twice. But that's not a problem. The junior developer could also first check whether the user is in cache, because he wants to be smart, right? He's checking here one more time. He's one more time increasing your hits or misses. And this is nothing you will find in your tests nor in your implementation, because here I'm just saying, here we see there is a cache, there's a repository. We think they are completely not coupled, but they are. Because we reason about traits, not about implementations, because that's what they taught us. And now I have an error because I'm asking cache twice. I have tests which will basically they will never find that mistake, and that's it. But you might say, somebody who's like really strong with OO might say, well, they didn't teach you OO right, because if you were actually being focused during university classes or whatever, you would learn that you take some dependencies and there's some contract. So there's a contract that, for example, repository will never talk to cache. Okay, awesome. But my compiler knows I'm just a human and I can make a mistake. Wouldn't it be nicer if that contract was actually implemented in the type system? If like this second developer, this junior developer, right, tried to make that error, tried to do something with repository, we will get an error. Or if it's already implemented, the repository actually is changing cache internally, we get that information from the type system. Would it be just nice if just types and compiler would tell us you made a mistake? That would be awesome, right? And after the break, which is like, I think like 30 minutes, John, is that true? Yeah. After the break, which is like 30 minutes, we'll try to look for a better solution where actually compiler can help us with this dilemma. See you guys in 30 minutes.